Please turn to the top of page 7. We're going to talk about lipid metabolism. And we'll start off, essentially it's just going to be two overheads on this. It'll be nice and simple. Start off with the concept of lipogenesis, which is one way of thinking of this is all roads lead to fat. Not all roads lead to Rome. That was acid-base theory. Lipogenesis, to make lipids. We're going to be talking about making triglycerides, your neutral fats. Essentially, we store it in adipose tissue. If we're breaking down adipose tissue, we start mobilizing it, but that's a different argument. So when are we going to make fats? When we storing fats? You're well fed, and that's the problem with America. We are too well fed. We have lots of ATP, lots of sugar around, proteins around. Store it for a rainy day. And so when we make these triglycerides, we will store in the form of adipose tissue. One of the building blocks of triglycerides is glycerol and fatty acids. So that's the direction we're going, glycerol and fatty acids. And if you look at this, where do I get glycerol from? Again, if you're well fed, all roads lead to it. Look at this. We have glucose, and essentially it goes through some changes. Follow the arrow. Glucose can give me glycerol through some changes. We're not going to worry about the details. If we break down glucose, we get this thing called acetyl-CoA. Don't get too stuck on that. But acetyl-CoA can be used to what? Create fatty acids. So with lots and lots of sugar, I get glycerol. Lots and lots of sugar, I get acetyl-CoA. And both of them give me glycerol, fatty acids, which gives me ding, triglycerides. But everything gives me fat. You don't believe me. Well, that's sugar. And obviously, if you eat fat, dietary fats, you have triglycerides going right into your body. So fat obviously gives me fat. Sugar gives me fat. How about lots of proteins? You ever see these commercials where you go GNC and they have these protein powders and they have some pictures of some really buff woman or buff guy and they're just huge, full of muscles, and implications. You take this protein milkshake and you get all buff, so you take you have those 3 of those protein milkshakes a day as you're watching football or basketball on TV, and you have those milkshakes as you watch a game of golf or tennis, and you have more of those milkshakes, and you're going to be fat, because in order to build proteins you need to do exercise, and only when you exercise are you really building proteins. So look at this, certain amino acids, but amino acids come from proteins, give me pyruvic acid, going up, go through some changes. Oh, we're back on the glycerol route. And certain amino acid can be used to give me acetyl-CoA, which gives me what? Fatty acids. And then, glycerol and fatty acids gives me fat. That's not good. So here we could have protein digestion. Remember protein digestion? That looks So proteins give me amino acids, and you just follow the pathway, and through lipogenesis, the wonders of trying to save up nutrients for a day when you may be starving. Problem is we're just not necessarily starving enough. But for every yin there is a yang, and we could build up, we could break down. We could break down using this process called lipolysis, in which we could take triglycerides and break it down into glycerol and fatty acids. It's not the exact metabolically reverse pathway, though we're not worried about the details. But essentially, if lipogenesis builds it up, lipolysis will break it down. So we break it down to fatty acids and glycerol eventually can be used and broken down ultimately to CO2 and water and ATP. You just kind of follow the pathway. And fatty acids too can also go down this way. So what happens when we do use fats for energy? Sometimes it doesn't work perfectly. If you're just burning some fats for energy and your body mainly uses sugar for energy, sugar's the #1 energy source, and you do use some fats. I mean, you exercise, you'll burn some fats. You do have a good clean burn. However, if you're mainly using fats for energy, and there's only two conditions where that will really be happening if you think about it. One, DM type 1, diabetes mellitus type 1, possibly type 2. Yeah, sure, why not type 2? Just diabetes mellitus. Sugar can't get in the cell, so you start burning fats. And it turns out when all you do is burn fats, it's not, think about like a Bunsen burner or your gas fireplace. You have logs. You want a blue flame, complete combustion. You don't want an orange, yellow flame. You get a lot of soot, incomplete combustion. So when you're doing this ketogenesis, you have an incomplete combustion, and you make ketone bodies, and we'll call that ketogenesis. So when you're mainly using fats for energy, the body doesn't quite know what to do with it, and you get ketone bodies. You may be starving. That could be happening. But these ketone bodies makes you go have what? Ketoacidosis. They're organic acids. Next thing you know, well, you're kind of breathing a little faster, trying to blow off that CO2. You get metabolic acidosis. Over time, you can break them down. You can get rid of them. Biggest thing is just to make sure you don't develop them to avoid the metabolic acidosis. Okay, let's see, anything else? In a separate video, the last video, last for this class. Oh man, there's going to be one more video left on cholesterol. But anyway, talk about energy yields briefly. How much energy? It turns out, well, you may think of lipids and carbs as being the same, and proteins probably being the least. It turns out that carbohydrates and proteins gives you the same amount of calories per gram of carb per gram of proteins. Lipids is twice. In other words, let's see, what is a calorie? It says amount of potential energy. If you're in chemistry class, that calorie is how much energy is required to raise 1 gram of water at 1 degree Celsius. So it's essentially energy. Potential energy, why are they calling it that? Because it has the potential to do stuff in your body, make your muscles work, active transport, help you grow, build things, and all that. When we look at this, carbohydrates and proteins are actually the same. So lipids give you twice the amount of energy. But the thing is if you're not using it, you store it. So lipids actually help you store more materials. Helps you store more weight for a given meal. Because if there's more energy, there's more stuff you can store. So actually, even though you have a gram, more of the lipids could get stored than the carbs. Maybe, I'm making up a number, a half a gram of the lipids get stored, so you have a half gram weight, but the carbs, it may be a quarter gram. The other half gram was actually burnt up for energy. So actually, you have a little bit more weight with the lipid than with the carb, and over time, that will add up. So lipids do have twice the amount of energy. So fats, that's why they say be careful watching your fat intake, but don't get fooled, because sometimes you read things that says 0 fat, but it's high carb. If it's high carb, what happens? You turn it into fat anyway, and you store it. So if you eat lots and lots of carbs, that's not necessarily getting around the lipids. It's just eating a well-balanced diet, not really too many simple sugars, though for a lot of us that's a problem. Not eating all saturated fats. There's your fish oils and healthier vegetable oils, extra virgin olive oils. Carbs could be more of your pastas and grains, and not Cinnamon Toast Crunch. And proteins doesn't have to be a saturated fatty piece of ribeye, though that tastes pretty good. It could be fish or chicken. So just eating sensibly.